the group at our department has two strong parts. One is hardware. You could see that the drones that they have prepared for the challenges are custom made with lots of specific sensors. These sensors are not on the UAVs for all the tasks all the time. We selected a subset which is specific for the task. So in some sense this reduces generality, but you see that you have to update your hardware for the specific tasks. We also, of course, the second part is software, especially vision. So this isn't just one example of some clever solution. In many of those tasks, you have to localize the robots with respect to each other, for instance, to avoid collisions, because more than one operate in the competition to fulfill a task. And this is an example of a clever solution where UV, ultraviolet LEDs are used, and with a filter, which is shown on the right side here, the black bar, with a UAV filter, you see almost nothing but these LEDs, and if they are flickering the right way, so you use time to code which is which, you can easily localize the drones. But so, of course, you need control software, you need power management, sensing, localization. This is just one example, but maybe the point is the multi-robot system at the department group at the Department of Cybernetics does not shy away from both hardware, software, and sort of intermediate solutions where the hardware does something and the software helps. Okay, so this is the flickering part. Now, the motivation for the competition is more or less attract top scientists to Abu Dhabi. They, for this competition, because they want to be serious, they contacted well-known professors in the robotics field. They do sponsor teams because they understand that to participate at a decent level at these complex exercises requires effort and some investment. And they do choose tasks which are relevant for applications in the industry, which you'll see in a minute. So this photo is there here mainly to show the size of the team, which will be progressively growing as the competition gets more complex. And you see that the Czech Technical University teamed with Penn and University of Lincoln. The Penn was there mainly because of their expertise in low-level control. University of Lincoln collaborated in vision at that time. So okay, I'll get on the sound. Maybe. So this is the preparation for the first challenge, and that will also, I will use it to introduce the tasks in the 2017 challenge. So the first task is to find colored targets which are placed on some small pillars, and you see here the training session. So our group really took the competition seriously, and they went to the desert like a month before, because the conditions are very different from what we have in Europe. It's quite windy, sandy. So the first task in the competition was, or one of the tasks, to collect specific discs which are colored and drop them into a box. You can already see it's quite windy, and this is the drop of the target. So okay, so this is so it's some sort of like collect items and drop them into a predefined box, maybe also sorting because there's more than one box. The second task was land on a moving target. So you will then see it later in the competition. There will be a moving vehicle with some landing platform on the roof, and the problem of the drone is to find the vehicle and land safely within a predefined area. Okay, so maybe I'm thinking that we perhaps could skip a little bit. So, okay, maybe we can go here. So this is already, maybe start from here. This is already, I'll use the original sound here. So this is from the competition itself, the vehicle is driving at the speed you see on the predefined trajectory, which is like an 8. So on the top right, you saw the view from the robot. On the left, from the spectator position. The landing creates some excitement. It seems a fairly simple task if you think about it like, okay, so what? It's a well-defined platform. But actually of those teams, I think only 2 or 3 landed, and then the speed of landing was important. So this is the second round, had to do it twice. So you see the drone first localizes the vehicle, and then in this windy conditions, you have to sort of synchronize with the vehicle, get the target, and here we were lucky. So it's just like on the edge, but it's okay. So that's the maybe you can think about as applications of maybe track a moving vehicle and land and deliver something while the object is still moving. Okay, so this is the part 2 of the competition. You see those discs distributed over the area, over the arena, and the question is that the task is to collect as many as possible and drop them in the box. Okay, so okay, so yeah, and I think the different colors are rewarded differently. Okay, so I think that's almost all from the 2017 challenge. You see all the nets around the arena. Despite that, I think one of the Japanese participants, drone, they had a sort of algorithm which had a sort of go home button if you lose your position in the arena. Unfortunately, they did not reprogram the home from Tokyo, so the drone sort of departed on the east and was never seen again. So these competitions sometimes create funny moments, and you realize that in natural windy outdoor conditions, it's not so easy to do even trivial things. You have to get right sensing, localization, control. Yeah. Okay, so I think we can stop here. I think you have an idea what this looked like in 2017. So in 2019, I'm showing the call for participation, maybe to give you an idea of the difference between the definition of the task and reality when you encounter it. So the task number 1 was capture an object, or maybe that is flown by another drone. So you have to first find the drone and the object on it, and maybe safely collect it. It's in the competition itself, if you manage to capture it and collect it and deliver to the defined place, you got more points. If you manage to catch it or sort of collect it but you dropped it, that was not fully rewarded. So you also already got some points for that. The second challenge was wall building, a challenge. So you had bricks which were equipped with magnets so that you could lift them with a magnetic arm or some device, and you were supposed to create a wall or wall-like structure. In sense, it means placing the object in a defined position and orientation. So this is what you see in the call for participation. Okay, and then maybe the most exciting third challenge is quenching a fire or firefighting exercise. So you have an area with a tower, which is a model of a building, with fires on the ground, which have to be covered by a blanket and put out. And then the second part, the most difficult, I would say, is that the drone has to get to the fire and pour water on it. Okay, so that's and then it should collaborate with a ground-based robot, which could be, of course, much heavier. And again, the ground-based robot could put blanket or water to quench the fire. Okay, or extinguish the fire. Okay, so that's, and in the grand challenge, you have to perform all three things. Now, okay, fine. So how did it look like in reality in the first task? So there are 3 UAVs. 2 have to destroy 5 colored balloons, and the other one has to intercept the UAV flying with the ball. So that's at the top right here now in the middle. So this is what you'll have to catch, and then you have to pop or puncture all those robots. We are using a RealSense camera, which is RGB-D, and for the capturing of the ball, we used a LiDAR. You'll see why. So these balls, of course, it's fairly easy to localize them, but still the color changes according to daylight conditions. We'll see a picture of the UAV, so we also have to have a device to puncture the balloons, and they are at a fixed height. You know the height before, so we use for navigation just GPS and IMU, consumer grade more or less. So in the end, our global position was quite imprecise. We could land in the predefined area, but maybe 2-3 meters. The integrated error. We had a LiDAR time of flight thing to get the height. For the drone interception, we used the LiDAR because it turned out that the cameras did not work because when we got very near, the ball was getting often out of the field of view. Or because it's also windy and also the drone creates some airflow around it, so it was difficult to keep it in the field of view. So we had this lurking approach where first we localized the drone, which was flying on a fixed trajectory, again like an H shape. You didn't know where it would be a priori. You didn't know the tilt of the trajectory, but you knew roughly the size. It was like a 40 times 20 meter loop. And we sort of detected it. And for the second round, we were waiting for the drone to come back. We managed to intercept it, but we couldn't hold it. By the winners from Beijing University, they had a chasing approach. So sort of get hold of it and chase. Yeah, so here's the flying thing. Okay, so we sort of hit the ball, but did not hold it in the net. Yeah, so you could see it was like a near miss. Yeah. So yeah. So all of these tasks have to be completed simultaneously, which means that the robots, the UAVs, should not hit each other. But it sort of made it a little bit easier because this is the trajectory of the flying helicopter. It's higher, it's above the area where you can expect the balloons. And the 2 robots which are popping the balloons, they can sort of split the area. Okay, so this is some visualization of what the model of the situation is for the robots in 3D. So perhaps you could see now that I chose to show this picture because you see, if you look at those at the drone, it had these pins to prick the ball on its edges. So you have to even consider such small things like how to do the final task. So find the balloons, get from the right direction, don't hit the pole, and prick it. Okay, so now let's have a look at task number 2. So again, the drones were again different. These were the capturing drones for collecting the ball. You see more details here, so perhaps I will not describe it. The picture speaks for itself. Now, challenge number 2, which is collecting the bricks. So let's look at that one. I think it's down here. So again, a slightly different setup. So there's 3 UAVs to collect bricks plus a ground vehicle, and we had the biggest problem. We had the biggest problem with dropping the bricks because we didn't want to sort of almost land. We wanted to drop the brick before the brick touches ground because that was difficult to control the UAV then as you touch the ground because you lose some degrees of freedom in the control. So this task is like localized. You see this fisheye camera that we used. You have to get to the right distance, collect it, and then drop into onto a fairly narrow and target area. So this is the preparation in the deserts, where again we use it because the wind is similar and the lighting is quite similar and things like that. So this is the wall. You see the that's the target area, then the bricks, and plus you have the 2 UAVs that must avoid each other. So okay, so again, this is probably modeling some sort of delivery type of behavior and some sort of in a collaborative scenario where there's more than one drone around. And then okay, we can skip the ground vehicle. This is not the place. We are in a UAV, not robotics workshop. So maybe for the recording, I inserted one image where you see the drone in more detail, so people who are in the business will recognize the components. Okay, maybe the third challenge is the most interesting one. So that's the quench the fire one. So there's 3 UAVs, localize and extinguish fires. One UAV is dedicated to ground fires. That's the one with the blanket. You see it there. You need a special setup, a claw mechanism for blanket deployment. Maybe I'll stop it in a minute here. So what you see here is this sort of a model of a fire. So there, this red piece of cloth is moving like, say, flames, and you see these thermal emitting parts here, which get hot, and they're quite nicely visible in the thermal camera because this exercise should test the use of thermal cameras. And when you put the blanket on this area, your scoring is like how many of these thermal emitting elements you cover. Yeah? So you have to find the fire, and maybe the main challenge is to put the blanket in a way that covers the area the best. You see that there's some fan, and now let's see what happens. You see on the right, you see images from the thermal camera. The bottom one, there's a front and bottom, and now, okay, sort of semi-success. Okay, so there are TeraB cameras and some RGBD camera. So this one is very tricky. Here you have to have a device that squirts water, and you have the thermal cameras for localization, the real sense camera to get the distance, also the LiDAR, some localization, and interestingly, the scoring, like it's difficult to measure fire extinguishing. So the organizers measured the amount of water that you managed to get through the hole where the fire was coming from. So first you have to find the fire. You can see it on the right in the thermal camera. Then it's about correct positioning. And since now your problem is that you don't have independent, or we chose not to have independent degree of freedom for controlling, let's say, the water flow. You had to control it by the movement of the UAV itself. So now your flight path, your flying control is integrated with your objective to quench fire. So one of the UAVs failed, so this type of things happen, and then we managed to localize the fire, and you see the details of squirting water, trying to get it through the hole. This is the ground extinguishing one. But you see that it's the end game, the final part, and managing to be precise is very, very important here. Yeah? And everything has to be done autonomously. You have the opportunity to sort of land all the robots, refill water, and then restart all in a 20-minute slot. So fine. So this is just a detail of how the arena looks like. This is the fire, that's the size of the hole, and now a robot approaching it and delivering water. Now I'll switch to the DARPA Subterranean Challenge. So here, the idea is on the rescue missions, and mainly, perhaps unlike this MBZIRC challenge, which is UAVs mainly, the DARPA is probably ground vehicles mainly. They are supposed to find perhaps victims of some disasters in underground spaces. The task is to localize things like a fire extinguisher, a body of someone injured. The challenge is that the communication, you have no communication with the robots inside, and if in this mining environment, you might have corners which even complicate communications between the ground robots and the UAVs. The UAVs could, you have to report location of found objects. And okay, so there we did, so there are like two types of categories. There are people who are directly sponsored by DARPA to do this. And we were the first among those that are self-funded, which sort of means that use cheaper hardware and so on, but still a nice result. The challenges there are communications. Once, for instance, you see an artificial obstacle. Well, you actually not artificial. You sort of hallucinate an obstacle, and while trying to fly around, we ran out of batteries. So all sorts of problems. Okay, maybe we can do it without the sound. So here you see the structure of the spaces. So you do have some, as usual, preparation time, and as I said here, the ground vehicles are more important than the drones. The drone setup in